Very good morning to everyone, and welcome to this course on responsible artificial intelligence, which we have planned with the Persistent Systems Limited. Shortly we'll be starting with the session. So before that, I would just like to introduce and welcome everyone. Pune Knowledge Cluster, I'm Prachi Pasirkar. I'm Assistant Program Manager at the Pune Knowledge Cluster. And the Pune Knowledge Cluster is an organization for Pune by Pune. The mission of Pune Knowledge Cluster, we all of us know that Pune is rich with all the prestigious educational institutes, academic research institutes, world-class industries are there in Pune. The mission of or the role of Pune Knowledge Cluster is to act as a catalyst to bring together large talent pool which is there in the industry, academia, government and non-government organizations to brainstorm on a particular problem or identify projects and work collaboratively to address these issues or problems. The Pune Knowledge Cluster has been established by the Office of Principal Scientific Advisor to the Government of India, and it is administered by Inter-University Center for Astronomy and Astrophysics, which we all know popularly by IUCA. And the aim of the cluster is to facilitate discussions and facilitate discussions within the academia, institutes, industry in Pune and around Pune, and to address challenging problems through brainstorming discussions, taking initiatives, using scientific knowledge, and engaging high-skill human resource that is present in the city. For doing this, we have all the mostly major organizations which are there in Pune on board. May that be academic institutes, government and R&D labs, private companies, government organizations, some associations with the government institutes, and also few international organizations on board with us. To begin with, we have identified, or the cluster has identified certain focus areas, which we call it as the verticals. They are, which you can see over here, it is electric and sustainable mobility, big data and AI, artificial intelligence, health, capacity building, green cover, environment, and sustainability. These are the few focus areas which we are currently focusing on. And the program which we are having, or the course which we are running currently, this course which we are registered for, falls under the capacity building vertical of PKC. The role or the the potential of this capacity building vertical is to, or the aim is to provide new opportunities for students, young researchers, professionals to improve their knowledge base and acquire skills through interdisciplinary training programs. The aim is also to bridge the knowledge gap or the skills gap that is there. When we take up a particular course, let's say be electrical, okay, and the thing which we learn in our syllabus, etc., is different than what is required in the industry. Okay, so it's also bridging the gap between what is required in the research institute or industry and what we actually learn. So since January 2021, the cluster has conducted 3 courses and 2 webinars, and two more are there. Two more are there in the pipeline, and many more are we planned. And yeah, so these are few courses that we have conducted earlier, and right now we are at course number 4, that is this, which you all have signed in for, and the Responsible Artificial Intelligence course. And to tell us more about the course, and also we have today's speaker here, Dr. Bhushan Garware. He's from Persistent Systems. So Dr. Bhushan Garware works as a senior data scientist at Persistent Systems Limited. And Dr. Bhushan holds a PhD degree and a gold medal and has 3 patents on his name. He has conducted many workshops and tutorial sessions on machine learning in several industries, academia, and research institutes. Dr. Bhushan has been nominated as a member of Board of Studies for Electronics and Electrical Engineering by Honorable Vice Chancellor of Savitribai Phule Pune University, and his research interest areas are explainable AI and assistive intelligence. So, very happy to have you here, Dr. Bhushan, today, and over to you to brief people what the course is all about and for your session.
Thank you so much, Prachi. Hope I'm audible.
Yeah,
I'm sharing my screen. Let me know if it's visible.
yeah, we can see your screen in
Thank you
full
so
screen
much.
mode.
Yes. Good morning, everyone. This is Bhushan. I work as a data scientist in Persistent, and it's my proud privilege to interact you today on this very interesting course on responsible AI. Today is the first introductory session in this lecture series. Before we get started, I'll just introduce you who we are. So we are Persistent. It's a 30 years old software company headquartered in Pune, and we are involved in innovative software solution delivering solutions to our customers and partners. We have presence more than 16 countries, and by the end of 2020, there are overall 12,000 employees. Without further ado, let me give you a brief overview of what this course would be. So there are 9 lecture series. Lectures will be delivered from Persistent side. There would be a last course on accessible AI where we would be sharing you a pre-recording session. Um Today we are here where I would be giving an introduction about what we're gonna learn. So these are the presenters for this course. So in the first course, I'll just give you a big picture what responsible AI is and why we should be considering uh, thinking about responsible AI, what are the principles and other aspects of it. In the next lecture, there would be a deep dive on interpretable and explainable AI, where I'll be mostly covering on typical structured data set and how this field evolved. And there would be a hands-on sessions with you on a real data sets. The lecture number 3 would be on interpretable and explainable AI, basically for unstructured type of a data set. So we will see some applications in NLP and imaging domain, how interpretability can be obtained. Then lecture number 4 would be on fairness aspects. And there are 3 sessions which are planned dedicated for the privacy preserving AI. Lecture number 8 would be again covered by me, where I will be talking about how can we develop secure AI solutions. And last lecture would be covered by Anibha, where she would be talking on reproducible AI and its applications in the industry, and where we would be more talking about a new emerging field that is called ML Ops. And the last section is more about accessible AI, where we'll be talking about human machine interaction and what are the aspects of designing an interface to deliver AI related solutions. So a question may come into your mind as why responsible AI and why now? Okay, so on 23rd of February of this year, there is a announcement from Government of India, Niti Aayog, where they uh, talked about, the approach document is also released. So everybody has realized that, there is a large adoption of AI technology into our day-to-day workflows. But while delivering solutions, we have to take care that all the solutions are deliverable responsibly. So what are those responsible aspects that I will be talking about? So in this course, if you ask me what could be the prerequisites of this, so this course is designed for the practitioners of AI and ML. We will not be talking about typical machine learning algorithms, how they design, how they are fine tuned, how to take a data, how to clean it, how to do feature engineering, parameter tuning, evaluation. Those aspects will not be discussed in this course. So we expect uh, the audience for this course are ones who are already spending good amount of time with AI and ML application development. So the journey starts that if you have a machine learning model in your hand, which has gone through all the typical iterative processes of building best accurate model, once you got a model which is highly accurate, then what next? So a story starts once you have a trained model in your hand. So views, thoughts, opinions expressed in this presentation solely belongs to the presenter and not necessary to the presenter's employer, organization, committee, or other group of individuals. Let's get started. So this artificial intelligence, we see that this term is used very loosely nowadays. You know, when the people are using simple linear regression, they still call it as we are doing AI. So it's very important to understand what are the boundaries, what do you mean by AI, what is ML, and what is deep learning. So I'll not be spending much time. Just try to understand that artificial intelligence is a subfield of computer science, where the job of computer science is to automate the things. But while doing an automation, AI takes consideration of four factors. While automating, your software should have ability to sense, to reason, to act, and very important aspect is to adapt. And there is a subfield of AI called machine learning, which enables machine to learn from a past historical data and experiencing without being explicitly programmed. So this is the difference between computer programming and machine learning, where you don't have to code as such. Algorithms figure out on their own. And there is a small field of deep learning where we take a help of a neural network to solve this. So AI, ML, and deep learning are not same, but if you see this, machine learning and deep learning are subfields of AI. So even if you are doing deep learning or machine learning, people claim that they are doing AI. Technically, they are right, but you should understand uh, the difference between the technologies. So sorry, but thanks for joining this course. So if I tell you, let me tell you some interesting thing about machine learning, nobody will come. But as I'm saying that it's responsible AI, there was a lot of competition to join this course. But again, I said deep learning and machine learning are subfield of AI. So all the responsible AI techniques that we're going to learn entire this course, most of them are applicable to the applications of machine learning and deep learning. But still, you can claim that you are doing AI. So what are the changes that we see in the technology? So typically, we call it as machine learning 1.0. So machine learning 1.0 is what there was a data scientist, and the main job of a data scientist was right from data set creation, performing feature engineering, choosing right algorithm based on an application, spending a lot of time playing with an algorithm, tuning the parameters, and eventually have some evaluation techniques in hand and come up with a trained model. So this, the entire ownership was done by a person called data scientist. And obviously there is scarcity of good data scientists in an industry. And after working this same process on different data sets, people in industry actually try to think, can we automate the above procedure? Can we have something which can perform the job that data scientists are currently doing? And that's why they claim the new thing that they call it as an automated machine learning. Now, there are amazing softwares developed by big companies like Google AutoML or Microsoft Azure Automated Machine Learning, SageMaker Autopilot, H2O.ai called driverless AI. So all these big companies, they claim to have very intelligent software. Once the data is thrown to them, right from problem formulation to feature engineering to auto algorithm selection, model tuning, model deployment, all that stuff is done by a bot. And that's why the second era, ML 2.0, is called as an automated machine learning. Now, by doing this sounds really exciting, you know, but the accuracy of AI model is undoubtedly the most important factor. However, only accuracy is not enough. All these tools will give you high accurate models, but there is a problem. And if you want to go deep into understanding what could be the problems in that, there is a very interesting book, and this book is freely available. It's an open praise from Springer. Have a look at this. Very interesting challenges are documented. Let me tell you a very interesting example why we need explainable AI in a business perspective. Imagine there is a bank and there is a customer of a bank, and this customer asks for a request that I want to have a credit line increase. Now, what this bank will do is it will ask all the related information about that customer, his history, his current income, past record, and create a feature vector, and then it will query the trained AI model. Now, once this AI model got all the features that the model wants, it will return a model score. And that model score could be a lending score. If it is a probabilistic model, it will see that zero point 0.3 is a probability, zero point 0.3, that is 30% chances that this person will repay. So what the bank person does is understand the what output is coming from the AI model, and it will return saying that, hey, your request is denied. Now, imagine the condition for the end user of this bank. I requested for credit line increase, and what I got is your request is denied. So the question that comes into their mind is why the request is denied and why not, and how I can improvise my credit score so that I can get the credit approved. So the problem with this kind of an AI deployment, we call it as a black box deployment, is this: you have a black box AI, nobody knows what is going inside those models. What you are getting is a poor decision back to your end customers who are, so you are not only happy, you are not only having unhappy customers saying that why I'm getting this decision and how can get a better decision. The entire ecosystem of a bank which works in the back end, for example, the business owner of a bank, he has a question in his mind because there is an AI model. I don't know what is going in the inside this black box. How can I trust whether the decision given is right or not? Business owner is in dark. There is customer support. If somebody calls, hey, I tried your application, my loan got denied. Can you explain me why my loan is denied? Unfortunately, customer support has no answers. There is IT operation teams who is continuously monitoring the behaviors of models. I got 200 applications a day, out of which say 100 applications are getting rejected. But how can I actually evaluate whether the model is doing right or not, whether I'm looking business or not? Unfortunately, the model is black box. These IT operation guys will not get any understanding of this. There is a data scientist owned by the bank to build a very accurate model. But the problem is, can a data scientist say that this is the best model that I can deliver? If the model is black box, if you don't know underlying behavior of this model, how can you claim that this is the best model that you have? And the last but not least is an auditor or a regulator. It's very important that this person needs to know if the AI decisions are fair or not. Is my model having some kind of a bias against men and women? Is my model giving some extra preference to some privileged classes? Right? So the problems with black box models is you not only have unsatisfied customer, but you also have entire support system which is struggling to adapt the AI models into their day-to-day workflows. So how this can be solved? So if you want to really bring AI into your day-to-day applications, your decisions made by AI should be explainable, they should be transparent, and they should be fair. And AI solutions should be human centric because eventually the end user of this system is a human being, right? So whenever you develop a system, it has to be human centric. So if you want to deploy a good AI systems into the production, which is a transparent, fair, human centric, these are some of the key pillars of a responsible AI. And the first principle of responsible AI that it should be interpretable and explainable. You should have some intuitive inner working knowledge of how the model is behaving. Your AI system should be secure and private. You must have some countermeasure against the threats that the there could be a security or privacy threats. We will have some deep discussion on that side. Compliance and ethical AI. Are you keeping up with our regulatory changes, socio-economical fairness in your models or not? And the last is reproducible AI. Whether are you keeping track of all the models that you are behaving? Can you reproduce a particular decision? Because at the time of audit, it is very important to actually reproduce some of the decisions made by you. And the last is accessible, how you can put expert in a loop because the systems are eventually developed for human beings. So you cannot think of actually getting rid of a human factor into the entire process. So these are the 5 pillars of a responsible AI. And let's have look into one into each other. So what is interpretable and explainable AI. A current state of AI is like this. There is a training data and there is a model building process. And mostly this process is executed by a data science team. And eventually, once a model is trained, that learned function is given to the end users, and let it could be a decision or a recommendation engine to the end user. Now, this end user is not always a technical person. It could be an customer, it could be a business person. So when a learned function is exposed to an end user, these are the set of the questions that are then mine. Why did AI do that? Why not something else? When did AI succeed? When do it fail? When can I trust AI? And how can I correct an error? But right now, with the state of typical AI that we have, we just say, I don't know. I'm saying the loan is rejected because my algorithm is saying so. But that's not going to help, right? So if you want to satisfy the end users of the systems, you will have to answer all these questions, right? Now, how to do that? Let me give you an example. So somebody will ask you, hey, I have a training data and I train my algorithms and it is showing you accuracy like 98%, 99%. So why I need to answer all those questions? Because when humans, they take a decision, they are not always able to explain why they took the decision. But in case of models, the story is different. Now, imagine there is an image recognition model, a deep learning model, like you get a lot of models trained on, say, ImageNet, where you have thousands of classes. So this is a model that is trained. Now, if you pass this image to this model, it will say that this is a guitar, and the accuracy or the confidence is 98.90. And then you can say that, oh, amazing, this is the right answer. But for the same image recognition model, tomorrow, if you pass this image, your model will say that am I audible? Someone actually muted me.
Yeah, you're audible.
Yep, thank you. Now, if you pass this image, your model will still say that this is also a guitar. And this time, the confidence is even more. It's 99.99% confident. So your deep learning models are not only wrong sometimes, but they are very confident about their wrong decisions. So you cannot think of saying that, say, hey, I will put a threshold. If the confidence is more than 80%, then only I'll accept the decision. It's not. When your deep learning models are wrong, they are pretty confident about their wrong decisions. And this is just a toy example, but the complications of this would be uh, very severe if you go to the regulated industries, right? So let me tell you a real life interesting example. Okay, so there was a story long back when a family in the US, they adopted a puppy, small dog, and after a few years they realized that what they had adopted was actually a wolf. So when this story was published, a guy decided to train a model, a deep learning vision based model, to classify a breed of a dog called husky and a wolf. So what he did is he collected lots of images of husky, that is a breed of a dog, and wolf, and then he trained his model by following all the standard recommended practices of building a vision model. Everything was good, and the accuracy that he got was 98%, which is pretty 95%, which is a pretty decent accuracy. But when he actually tried to test this model, this is the image of a wolf. The true label was wolf and predicted was also wolf. The predicted was husky, true label was husky. This is kind. But for this particular image, the true label is husky, but the model predicted it as a wolf. And what could be the reason of this? You can clearly see in this image, looking at his eye, somebody who is a pet lover can realize that, hey, this is husky. but your deep learning model made a mistake calling it as a wolf. And when the explainability techniques are applied on these kind of an images, what it got is why what bias that got into the model is all the training images that was used in the model building process. When there was a wolf, there was a snow in the back, and all the images of husky were, domestic images taken in the house and the garden or somewhere else. So your model is not able to figure out where to look into. What the bias that caught into model is, model has learned to see a snow in the back, and whenever there is a snow, model says that this is a wolf, right? And that's why the explanation is important. And this is an amazing example given in a paper. The paper was published in 2016 called Why Should I Trust You? And a very interesting method called line that we're going to learn in our next lecture. I'll open up how these explanations are generated. But when the explainability techniques are applied, it says that my neural network is not looking at an animal. My neural network is actually looking at the snow in the back. And then you will figure out that only accuracy is not enough. It is very important for you to figure out whether my model has learned the right features or not. And that's why interpretable and explainable AI is of a great importance. The same example was seen in one of the healthcare application. Now, current situation, you can relate to this. So this paper was again published in 1617 by Microsoft research group. Similar situation. So there was a hospital. Now you can relate it to the COVID cases. Um, there are very limited ICU beds available. So whenever a new patient comes to a hospital, there was someone who was taking a decision whether that person should be admitted to ICU or whether that person is allowed to go out, not in an ICU, because there are very limited ICU beds. Now, as decisions were made by humans and a lot of historical data was available, what they decided is to train a machine learning classification model, gather all the uh, biomarker reading, historical readings of the patients, and then let machine take a call whether the person should get admission in ICU or not, right? So how they formulated the problem is, from the historical data, the patients who died in next 7 days, they consider that these patients we should have admitted because they lost their life in next 7 days. So a critical treatment should have been given to them. And the people who survived more than 7 days, they put them on the hold. Okay, so this how, because the real life data says you have to create the data in a machine learning friendly format. Nobody gives you nice CSV data that you can simply call model.fit x comma y, right? So this is how they formulated a problem. And again, neural networks were used and an accuracy was really good. But the problem is, when explainability techniques were applied, there was a column in their data set which has asthma column. It was a categorical column. The patients, this is all the patients were pneumonia patients. So how the problem is formulated is, in history, the people who died in the span of 7 days were treated as should be admitted to ICU in future, right? Now the model was really good, but the problem happened is, in that model there was one factor called has asthma. So what the model is trained and what was the bias caught in the model is like this: if a person is having asthma, the risk of death is less, and the patient is not having asthma, the risk of death is 12%, which is contradictory to medical philosophies. This has happened because in the history, the patient who complained for pneumonia, they were already taking some treatments for asthma from other hospitals. And because of those other treatments, they could survive actually. But that doesn't mean that if a patient having pneumonia has an asthma, has no risk of death. So this is a wrong thing that got learned by the model in order to make a prediction whether there is a risk of death or not, right? So if you talk to actually doctors, they will say that pneumonia and asthma is a deadly combination. So you can see these kind of a biases that getting into our data, we feel that on paper our algorithms are highly accurate, but there are real life implications are really bad. And I can give you some nice examples. If you are aware of some embedding techniques like word2x or glow, and there are some analogies. So if you check the analogies into these models, you will see that man as to doctor, woman as to nurse. Now will you accept this kind of bias? Why you why woman as to nurse, can't woman be a doctor? But that kind of a bias which comes into your data, and it is very important for you when you train your algorithm, your the prediction of your model has to interpretable. And if it is not, you have to change the way the model is trained. And you can play with this one word analogy example, and you can get some strange results like man as to software engineer, woman as to homemaker, right? Man as to professor, woman as to assistant professor. Now, why this is happening? There is no, because model has no brain. It gets trained the way you feed the training data to it. And unfortunately, there are more professors, men, and more assistant women professors, right? So that's how the bias gets introduced in the data. But the one thing that we should say that these things are not acceptable, and we will have to open that black box and try to figure out what is going inside it. And that's why interpretable and explainable AI has of a prime importance, right? So how we do that? So a typical procedure of training AI model that we are doing so far is the standard AI. This is the data, this is a model, and how we were doing so far is we have to have a generalization error. The whole game is how can I minimize the difference between what is predicted and what is actual. So here there are no constraints. You are saying that you find whatever features that you want, whatever the weights of the neural networks you have to change. What I want is a very minimum error between what I'm predicting and what I have. But this is a black box way of doing the things which are not acceptable now. So what how you can change it from standard AI to explainable AI? From standard AI to explainable AI, you have to bring an explanation interface in between. So there is a human who will continuously watch the way in which your model is getting trained and what things to watch, what are the metrics, what are the methods, that all you will be taught in my next lecture, where we would be deep dive on explainable and interpretable AI. So this orange box that you are seeing, that how to generate this explanation interface, is a very interesting aspect that we will be learning here. Okay, so what you want is not only generalization of error, but also you need to bring a domain expertise. So this is a human which plays a key role, which will see the explanations generated by the model, and if those explanations are in line with their domain, then only this person will approve the deployment of this model and you will go further. And that's a journey of explainable AI. So how the end system will look like? There will be same process of training a data, same model building process, the way you built an AI model. But in addition to that, you will have to have one more module into your system. And this one more module is called as an explanation interface. So this person will not only get the decisions of your AI system, but this person will also see the explanations of your system. And if this person is happy with the explanation, then only it will actually take this model for the further things. So what I was explaining is the situation is still same here, that you will be still developing your AI models. Again, your whole concentration would be on building a very accurate AI model till this phase. But that orange box that I'm seeing is a new thing that you will have to do, because unless and until you are not generating explanations, you are not giving justifications for your AI models, people will not adopt it. And in our industry also, I experienced this kind of a reactions from our customers saying that, hey Bhushan, I understand that your model is accurate on paper, but can you justify the decisions made by your model? And this justification is very much important when you go to a regulated industries like banking and finance or healthcare, right? And that's why interpretable and explainable AI is of prime importance. So what we will be learning in the next two lectures after this is, if I'm having the black box AI models, and I'll define in depth what do you mean by this black box AI model. Your job is to take this black box and make it transparent. So this is a journey from black box AI model to an XAI, that is a transparent artificial intelligence. I'll not go deep into it, but all the big companies, they are developing different techniques to explain the black box models. And there is a, so I'm giving you some references. You can search for explainable AI by Google Cloud. There is a very nice toolbox by IBM called AI Explainability 360, open source. You can play with it. There is an interpret ML from Azure machine learning, and there is an explainable AI for H2.ai. So you will definitely realize that all big companies in the market, they have realized the importance of explainability and interpretability, and that's why all these very interesting toolboxes are coming up, and most of them are open source. So you all are encouraged to make your hands dirty with this toolbox and deploy responsible AI models by having an ability to generate interpretations and explanations to your model. I'll not go deep into it because there are two dedicated sessions on this topic, which maybe first of that will start in the next Monday. Okay, so you can take a note of this, and we will be having a hands-on session there. Now, let me move to the next important pillar of responsible AI, that is called secure and private AI. So few days back, you must have heard there was a news from Cambridge Analytica, and there is a scandal where the privacy of a lot of Facebook users was compromised. At first place, people put all their private information on Facebook, all their photos, all the details, and then all of a sudden they have realized that our privacy matters, right? So what has happened, and what are the typical methods that are used to protect the privacy of the users in the machine learning system? So a very interesting thing is, whenever a survey is conducted or whenever a patient data is shared for training AI or machine learning algorithms, what people feel that, okay, let me anonymize the data. So data anonymization means removing your personal information, removing your name, your address, your phone number, sometimes your gender and age, so that you feel that, okay, now you can take my data because my all details are not there, and I'm sure that my privacy is preserved, right? So this is how typically people traditionally follow a method of, you know, securing the privacy of the users is, you know, take an original data and create a process data where they remove the names, make some alterations to their age and genders, and add the things, right? So far people were very happy saying that, yes, I'm secure and everything is going well. So how many of you are aware of Netflix Grand Challenge? So a very interesting thing, Netflix, you know, it's a video streaming company. Obviously, what they want is to create a good customer experience. They want very good recommendations running on their platform. So if you have seen this movie, you may also like this kind of a movie. And the more good recommendation that you bring, more people will be on a platform, and eventually the business will be more, right? So they had their internal data science team, and they created some recommendation system algorithm, and then they hosted a challenge saying that it's called as a $1 million challenge. So if you develop a recommendation engine which is 10% more accurate than what Netflix internal team has developed on a given data set, then you will get a prize of $1 million. And this, you'll see the prize was given. Okay, everything was good, but now the data anonymization was cracked. When the Netflix shared the data outside, obviously they anonymized the data, who watched particular movie, their details, their email IDs, everything were anonymized while giving a data for competition to train their models. However, this data anonymization got cracked, and there is a very interesting data set, very interesting paper which is called robust de-anonymization of large sparse data set. Uh, Arvind Narayanan, and this paper is available. Have a look at this paper, and what they said is there is another data set called IMDb, and this IMDb movie reviews data sets is an open data set. People log in and give the ratings. So what they did is the ratings given by people on particular movies in an IMDb data and the corresponding nature of the reviews given by the people on Netflix data set out the names and the details of the all people who were there in the Netflix data. So data anonymization, a simple technique is no more helping you out to preserve the privacy of the end users. So a big concern in developing AI ML model is how you are taking care of a security and privacy of your AI models. So a big uh, branch of a research who is working on that side, and at a very high level. And again, we have 3 dedicated uh, lectures on this area where people will be talking about different ways of handling privacy issues. And there is a dedicated lecture on how to avoid attacks on your system, how to make your model secure. At a high level, I'll give you an idea. The one way of securing this is you can perform data encryptions. So what you used to do is you used to take a raw data, you train your model, and then you generate an output, right? So one way by which you can still preserve uh, 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 the security is you take a data, you apply encryption to it. So data got encryption, and you train machine learning model on encrypted data. Do not train your model on raw data. So whatever coming to your machine learning model is not a raw data, it's always an encrypted data. So train your model on encrypted data, and the outcome that you get would be decrypted at a client's end. So everything will happen on encrypted data. So this method is called as homomorphic encryption, and then it's a very popular thing and active research area. There are some issues people are still struggling to, training at scale on encrypted data is very difficult. And I'm not an expert of this field, but experts gonna share their learnings from this in the coming up lecture series for you. Another way of doing it is a differential privacy. In a differential privacy is like uh, again at a very high level. If I'm as Bhushan and my readings are there in the data set, and you train an algorithm and you got some level of an accuracy, and now from a training data set, if my readings are removed and then you train your model again and there is no change in accuracy, that means I'm secured. That means my privacy is secure. This is at a very high level. But again, as I said, we are having a dedicated session on differential privacy for you, where we will be covering all these interesting techniques, how to preserve the privacy of the users in machine learning domain. Very interesting area. And you will see that, as I said, all the big companies, they have realized the importance of this. Machine learning is getting popular, but the privacy of a user is a high concern. So you will see that Microsoft Azure has supported this library called white noise to take care of differential privacy. Apple has its own library on differential privacy team. Facebook is protecting privacy on all the mobile data that they are having, and Google is also working on differential privacy techniques. Again, uh, a short comment that all the big companies have realized the importance of privacy, and it's going to be a pleasure for you to understand how you can incorporate that factor into your AI models when you are deploying. Then only you can claim that I'm doing responsible AI. Okay, not only accurate, not only explainable, but also I'm taking care of the securing the privacy of the users of which I'm taking the data. Now, let me discuss some of the attacks on your AI system. So we discussed so far on the security, on the privacy aspects, privacy of the users. Now, this is something very interesting where how you can make sure that your AI models are secure. There could be attacks on your AI models. And this is a very interesting vision example. So most of you must have heard that there is a data set on Kaggle called diabetes retinopathy, different levels of diabetes retinopathy. So this is an image. When you pass it to a model, this says that this is very good looking image. There is no sense of diabetic retinopathy here. This image, chest X-ray image, says that this looks like a normal X-ray here. The lungs are clean, everything is good, no opacity observed, right? But these are called as perturbations. The small changes done on your image, the changes are so small that for your naked eyes, you will not even realize that the image is compromised. And that's the beauty of these attacks. So those kind of examples are called adversarial examples. And here you will see that now for a human being, this image and this image is same, but for your neural network, initially your network was calling that this is a no diabetic retinopathy, but now it start calling it as a diabetic retinopathy. So your model is fooled by doing some perturbations on an image, and your model is not aware that it is being attacked. Okay, so this is very interesting because people are trying to put AI models into auto healthcare claims, processing and everything, where you say, hey, the person was admitted, he was having COVID, and now he is not having COVID. So this is at the time of admission, and this is at the time of going out of the bed. You will see that people can make changes to your X-ray images, which was very difficult for you to even figure out that those images are compromised, but they can fool your networks. Okay, and this kind of an attacks are called adversarial attacks. How to prevent those attacks? We have a dedicated course for you called Secure AI, where I'll be talking about first how to detect that there are some attacks, how to diffuse them, and the third one is how to train your system so that you can catch such attacks on your systems. And that's why secure AI is one of the very important attacks. And there are different attacks, and probably when we get a chance into that course, I'll be talking more about different types of attacks in AI systems. But hope you got the point. This can go so serious that how many of you worried that when you go to an hospital and do some radiology imaging like MRI or CT scans, so from the I work a lot on healthcare images, so I understand that these images are archived in a DICOM format, and while sharing this image, there is a DICOM header, and from DICOM header, all the person related informations are stored. And as I said, like an anonymization, what you can do is you can remove all the patient related information, and you can share the core um, image to the core image like this, no information about the patients. But there is a nice paper which got published in the New England Journal of Medicine. They say that this is very alarming, I would say. From CT and MRI images, they have a facial reconstruction. It's called a 3D rendering software that creates something like this. And once you have this 3D image ready, you can still recognize who the person is. Now, where is the privacy, right? So it's very important to save that. And as we are developing new algorithms, these are the different things that we have to take care about. So sharing the data, if you are having healthcare models, how you can train your models so that you can prevent the privacy of users. Very interesting things, very open-ended research. Let's see at what level people have succeeded to solve this kind of a problems. But remember, this is a cat and mouse game. You will develop some techniques and people will still find some ways to attack your system. So we will have to figure out how we gonna solve all those things. Okay, so this is about the security aspects. Now, this is again a very interesting factor. When the question was asked to Peter Noveng that how your models are so accurate compared to other people model, then Peter Noveng said that we don't have better algorithms. but what we have is a more data. And you will see that now, if you keep eye on latest publications in AI and machine learning domain, the leading conferences, you'll see that they have terabytes of data, at least few tens of GBs of a data in which they train their algorithm. And we struggle to get a GPU machine to train our algorithms, and people train their algorithms on clusters of GPU machines. So how can an individual like you and me can think of sitting in a room to come up with an algorithm which is accurate than somebody else? What he says is, I don't have better algorithm. What I have is more data. And to train on more data, what you need is large amount of compute, right? So how can you stop these big companies by by leading this, saying how to train the systems and all, right? So what if users say that? So imagine you and me, and if we start saying that, hey, from today onwards, I will not be sharing my data to anybody else. If everyone on this earth thinks like that, I'm worried about my privacy. I'll 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 make settings in my cell phone such that my data will not go outside. What will happen, right? Think about it. I'll ask you this question after 2 minutes again. By the time, let's try to understand how developments are happening. Initially, we again at a level one of AI and machine learning models, what we had is, the model used to be trained on cloud, because most of the time the training data is huge and it is saved in the cloud, and you have a nice compute in cloud. So the model used to train on cloud, and model is also hosted on cloud, and people used to capture the data on their client devices. Once the image is captured or data is captured, they used to query the model which is residing on cloud, and they used to get their prediction results back. So your training model was residing on cloud, right? So as you now progress and now you are having cell phones which has a good data storage and good compute power, now you have like 16 GB, 32 GB of RAM on your cell phones. People saying that, hey, can we take this train model out from the cloud and put on your cell phone? So what people do is, for inferencing purpose, you train your model on cloud, but take that trained model back on your cell phone. Now you can see interesting AI/ML application that the moment you capture an image, immediately you see the outcomes. And some funny application like smart Snapchat and something, they take inference on the device, right? So what is happening is, training is still happening on cloud. So you have to bring all data on cloud, and the training will happen there, and the trained model will be there on your cell phone, and the inferences will be taken on the cell phone, right? Now, what could be the next step? The next step is, can I train my model on the device? Now, people are saying that this is a logical step. Can I train my device on, or can I train my model on the device? The another aspect is, as the people are getting aware about their privacy issues, what if people stop sharing the data, saying that, hey, this is my private data, it should not leave my cell phone, I'll not be sharing my data. So what the big companies do, because the data is new oil, and if you start getting the data, what the big companies will do? So the solution for this problem is a new technology where you can say that I can train a model on the device. And this technique is called as a federated learning, also called as a privacy preserving AI. So a beautiful concept, very similar analogy to Hadoop like a system, a distributed computing, little bit different, but very close to that. What people will say that, hey, you're worried about your data, right? So don't share your data. Let the data be on your cell phone only, be on your device only. What will come is, rather than data traveling on internet, what will happen is, model will come to you. With a very interesting example of a banking domain. Imagine there are 4 or 5 different banks, and every bank want to develop an algorithm for fraud, credit card fraud prevention, right? So this is a bank one, this is a bank two, this is bank three, and this is bank four. Every bank, they want to come up with an algorithm to prevent credit card frauds, right? Now, because this is a transactional data of their customers, every bank will think that, hey, this is my private data, and I'll not be sharing my data outside. Whatever compute, whatever training that you have to do should be done on premise within a bank, right? But credit card frauds are of a different nature, and in different banks you will feel that different types of the frauds are happening. So what every bank wants is, I want a very accurate fraud prediction model, but I'll not share my data. Okay, how to solve this problem? So to solve this problem, there is an interesting philosophy which is coming up. It's called as a federated learning. What people will do is, they will take some publicly available data, and from this publicly available data, you will you will train a first cut model, and this first cut model would be there on your cloud, and every bank will get a first cut model on their premises. Now on the premise of the bank, they will have their own private data. Now on their own private data, there would be an incremental fine tuning done on the basic neural network which was used to train the baseline model. This bank will fine tune that, so there would be a weight alteration. They got the default weights. So the change of weights, how much the change that has happened to my neural network weights, that weights would be shared back to the server. Okay, and at the server, there will be a different data, model aggregation strategies. The simple could be an averaging, but there could be different interesting methods, and you have a lot of scope to come up with your own strategy in which all those change in the weights are clubbed together, and a new version of a model is shared to every bank. Now you'll see that bank number 2 got trained on their own data, but the effective new weights that was shared to the bank, which has a learnings from other institutions as well. So this is beautiful thing saying that, hey, I will share my small chunk of a data that will not go outside, but the learnings are carried out in the form of weights, and I'm happy to share you the weights. So on an internet, what is traveling is only model weights. Are you with me? Now somebody will ask me a question that, hey Bhushan, how can you take care of the security of those weights? What if in between there is an attacker and who actually attacks on the weights, then entire ecosystem would be breakdown. So again, people will say that, hey, those weights would be encrypted. So raw weights will not travel, the encrypted weights will travel. So there are, again, very interesting issues, and then you will have to come up with interesting solutions for that. But this is a very interesting, and again, I'm telling you, we are having a dedicated lecture on federated learning for you, where we will be discussing, and there could be nice examples for you as well. But this is again another area where you have to deploy a responsible system, especially if you're working with a data like banking or healthcare data, where the privacy is of a prime concern, right? So that's the concept of federated learning. I'll move on. If somebody wants to double click, these are the different platforms on which you can play this federated learning philosophy. TensorFlow federated, machine learning on decentralized data. You have a framework called PySwift by OpenMind, and FATE is an industrial level of federated learning framework. So these are the references I'm giving to you, but hold your excitement. There is a dedicated session on this part in this course of responsible AI. Now let me talk to another pillar of responsible AI, which is called as a compliance and ethical AI. Some interesting example. Now at the right side, there are two people of a different skin color are playing the game of a chess. Uh, the custom is that white goes first, and I'll rest you to read at. Now, this kind of biases are getting introduced, and there are some socio-economical factors to it, but it is not advisable to deploy AI system which discriminate people based on these factors. And that's why fairness in AI systems is very important. Let me give you another example. So this is the image taken from Amazon website. This is an Amazon Prime same day delivery, and this is the city of Boston. The area which is colored in the blue, the people living in that area, they get same day delivery on Amazon Prime, but except only this region of the city. Now people will definitely ask the question, hey, this is my city, and you give me same day delivery at the north, east, west, south, all the corners of the city, but why don't you deliver here in the between of the city? And when it was evaluated, the population of blacks were more in this area. And then obviously Amazon says that we have not done this um, deliberately. This is all data driven. We have not created some kind of a rules, but my algorithms has figured out that where you should be giving the same day delivery based on the customer or previous experiences, right? Now you will definitely understand that your AI ML model not only should be accurate, they should be fair. So what will a person will feel who is staying here, that I'm unfortunate that I'm not getting same day delivery, even if I can afford to pay exactly the similar things what others are doing at the other corners of the city, right? The same different biases that you will see that there are racial and gender biases. So this is a news that your facial recognition is accurate if you are a white guy, because the training data which was used to train this algorithm, it is not having a very good representation for all the different skin colors. And Google also then publicly admitted how there is a bias in their algorithm, in their image recognition algorithms, that a Google photo tags two African American ladies as gorillas. you know Now this is strange, right? How what a person will feel that if your image recognition model is calling yourself as a gorilla. Now what is the reason behind that? The reason behind that, the models are trained on the data which is not having good representation across all the skin colors and races and the genders. Now what you will do by taking such an accurate models? Now in your pipeline, when you build your machine learning models, apart from your typical accuracy measurement models, right? This like precision, recall, F1 score, area under the curve, you check that only for accuracy, right? But do you check all those factors for fairness? Are you really worried whether your model is same across all the protected features like age, gender, race, skin color? Not really, right? But what could be the complications of deploying models without having fairness considerations? These are very important pillar of building responsible AI, which are opening up very good research opportunities for all of you. You can go on Google search and you can type a keyword CEO. All the images that you will get are the white men. Why can't a black skin color person be a CEO? You'll see that all they are men. They're not even a good representation of women. And there are no representation of black men. And this is all happening. And every day, right now during my session, you go and Google it, you will get a similar kind of outcomes coming, right? So these biases are everywhere. Our AI/ML models, our information retrieval systems, they are not fair, right? And the things is people are losing their life. Millions of black people are affected by racial bias in healthcare algorithms. When you put a healthcare claim, their claims are getting rejected because those are submitted by the black people, which is completely unfair. And I hope you all understand the seriousness of all these things, right? So fairness is about an engineering. And again, I'm telling you, we will be having a dedicated lecture on fairness of AI model. We call it as a fairness AI, right? So how we deal it? So in our company, when we develop a solution, what we do is at the time of problem formulation itself, we ask the question, what will happen if my model is predicting wrong results? What could be an impact of that wrong decision on end user of this? It starts from that, whether it is ethical to replace your current workflows with an algorithm or with a software, right? Then we create, when we generate a training data set, we always check that if there is a bias in the data or not. If there is a bias, we use some technique to find out what is the bias, mitigate that bias, and then we train an algorithm. Now, this question you need to ask yourself, are you really worried right now when you get the data set? What people are worried right now is my data is unbalanced. I have very few positive example and very less negative example. But within your positive and negative examples, are you worried if they are equal across genders, if they are same across races, skin colors, genders, age, financial conditions? We don't care about it, right? But that's not a responsible way of developing solutions. At the time of algorithm selection, right now we take focus only on I should have a high precision, I should have a high recall, right? But are you saying that I should have high precision for men as well as women? I should have a high recall rate for all the races. My algorithm should behave similarly for all the different financial conditions people. We don't care about it, right? And that's why there is an importance of fairness. So if you want to deploy your AI/ML solutions, make sure that they are fair. And that's why we have a dedicated course on fairness AI. Before I move to the next course, I just want to think for this, for how many years you are using a band-aid? Anybody thought why the color of the band-aid is like this? The color of the band-aid is to match your skin color. And amazing tweet that get got it. Finally, after so many years, I got a band-aid which matched to my skin color. See how many years we are living with this kind of a unfair systems. So if you want to deploy responsible AI solution, make sure that they don't do discrimination across gender, across race, across skin colors, right? And that's why it is very important factor. How to do that? So there is a very interesting toolbox called AIF 360 by IBM. This toolbox is open source. They have 70 fairness matrices to check whether your data is unbiased. And there are 10 state-of-art bias mitigation algorithms. So the procedure is take your data, see if there is a bias into it, mitigate it, and then train your algorithms. While doing that, you may lose on some percentages on accuracies, but in the other end, what you get is a fairness model, right? Fairness of AI, a big factor while deploying responsible AI solutions. Let me move forward. Apart from AI 360, there are some very interesting other libraries which are coming up. And again, I'm telling you, there is scope for you to come up with your own metrics. But right now, you can find Audit AI, there is Thermos ML, Fair ML, Fair Learn, many libraries are coming up. Okay, so definitely make your hands dirty with this. And obviously, we are having um, some uh, some interesting examples and notebooks for you when we go into the separate session on this fairness AI. The second last pillar of this responsible AI is reproducible AI. this reproducible AI is a very, am I audible? Hello?
Yes,
Yes,
we
yes.
can hear you.
Yes, thank you so much. Sorry, I got another fluctuation here. Okay, so the next pillar that we would be discussing is about reproducible AI. Now, why your AI system should be reproducible? So there are two aspects of it. One is an academic aspect. Okay, lot of interesting papers are getting published. People are making associations with healthcare companies, astronomical institutions. They have a humongous amount of a data, and all different domains people are developing applications. So when you publish a paper, what you do is, this is how I train my model, this is how I got the data. Because of security reason, I'll not able to share the data. Because of the company policies, I'm not able to share the code, but this is how we got, and this is the accurate model I have. How can I evaluate that whether you have really done that or not? Right? So so there was a program on reproducibility in EuroIPS 2019, where some interesting recommendations are given, like when you submit a paper, make sure that your work is reproducible, what details you should be giving. So to solve this reproducibility crisis, there is a academic unit who is making sure that this is a checklist, make sure that you follow all these rules when you publish your papers and everything, right? So this is the academic side of the reproducibility. There is another side of reproducibility when you want some legal clearance from like FDA clearance or some other banking related application clearance for an audit purpose. When you say that, making sure that your model is consistent by when you provide similar type of an example, it produce consistently the similar kind of results, right? But in industry, reproducibility has its own importance. So this is how we call it as an experimentation tracking. In a span of 1 year, lot of things, because machine learning is not similar to your traditional software product development. It requires lot of experimentations, and you have to log everything that you do. So when you get a data, there are 10 different pre-processing techniques that you try, and there are 25 different feature engineering techniques. There are hundreds of algorithms, and every algorithm has their 10 to 15 different parameters to tune on. And a data scientist keep on playing with all these permutation combinations. But how you will take a track of all the experiments that you are doing? So there has to be a mechanism by which, there has to be a system by which all those things are logged. Okay, and you will not be doing this manually because it's impossible, but there are interesting tools to do that. Okay, so not only the data pre-processing, the version of a data on which you train your model needs to be saved correctly, because you know that it's not like you train a model once and then you are done. You have to retrain your model, you have to keep eye on a new data, you have to monitor how your model is behaving. All those aspects need to take care under a philosophy called reproducible AI. And it starts from experimentation tracking, deployment of your model, post deployment monitoring, understanding data drift. It is very important. My model is not accurate because of what? Because the model was trained on a particular data, and these were the statistics of this data, but the new data on which the inference is being taken, it has a different statistics. So there is no problem with my model, there is a problem in the data that I got. So I need to retrain my model. Who will take this call that there is a need for retrain, or there is a need for refresh of my AI model? You have to have a platforms for that. So there is a concept of data drift. There is a concept of there is another aspect called as concept drift. Concept drift is altogether different. The relationship between my variables is changing over the period of time. When I trained the model, the relationships was different. Though the statistics are changed, the relationships between the data have changed now. You can't do this manually, and there has to be a platform for this. And that's why there are interesting platforms, and ML Flow is what we use a lot in an industry. Is an open source platform for doing most of the interesting things for do. But there are many private players now who are coming into the picture and providing a platform so that a data scientist can focus on the core data science activities, and these platforms will take care of all the audit purpose and experimentation logging and monitoring and auto deployment and auto tuning and infrastructure management. Everything is taken care of by these models, right? So that's a factor of reproducible AI. And again, we have a dedicated course on these concepts where Anibha will take care of all the aspects and explain you how to do it. And people who are doing PhD, people who are actually doing their uh, graduate courses, this is my experience when I go in the colleges for evaluating, taking their vivas of their project. uh, it looks so simple, right? I took a data, I trained a model, and I got the results. But when I asked them, show me your experimentation, what different things you have tried, students have no answer. They don't track the things, right? So it's so simple. You can use some libraries called MLflow. You have a server and log all your experiments so that you should be able to track what I did few months back, what were the results. Now if a same data, if I pass to my model number 10, my model number 25, how can I compare the accuracies across different versions of this model? This is an amazing but very important activity to do, right? And that's why reproducible AI is of a prime importance. Last one is accessible AI. Sorry about some disturbance from my side. Last one is accessible AI. So this is IBM designed for AI, and as I told you, there is a there is a there is a dedicated course designed by IBM. So rather than we teaching it again, I would recommend you to go that course on your own, and it's free. It's a 3 hours course. Anybody can enroll and get their self and get it. Get the learnings from there. What they actually want is right from the business to business, how a typical AI model trains and what factors you need to consider to design an AI. So this is the course that apply design thinking to an AI. And because as I told, AI systems are designed for humans, so human in loop is important. And while designing your algorithms, you should take care of all those design thinking methodologies. So this is a page, you can find this course here. I would request you to do this course on your own at the end after Anibha finishes uh, her session on reproducible AI, and that could be the closure for their course. So today I had um, a, 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 a high level, I given you a high level journey of what exciting things that we will be doing. Here I will be meeting you next Monday, and on next Monday I will be covering on deep dive on interpretable and uh, explainable AI. And you will be getting some instructions for the next lecture or an email. I'll be sharing you some IPython notebooks and some instructions to download some of the packages. So next year we would be doing hands-on together. So I'll cover some theory and then some examples on interpretable and explainable AI. That's how the plan is. And after tomorrow's lecture, the further instructions would be given to all. So that's it for today's session.
Yes, please feel free to ask questions. You can also type it in the chat box.
Yes, and if there are no online questions, these are my credentials. I'm happy to get your feedback on the course. Am I going fast? Am I going slow? Whether I should be going deep into some topics. I'm happy to take your feedbacks and improve on that. So,
Dr. Sham Sundaram is asking that,
Yeah,
saying
Bhushan.
that it is a good session
Yeah,
and
Bhushan,
can,
Sham here. Hi.
go ahead, sir.
Yeah, Bhushan, fantastic session. I think you have covered many of the areas. One thought I would like to suggest, there is one learning which is, I think, called as what you spoke about, the federated learning. And there is
Yes.
also another kind of learning which they call as smash learning, okay, which is by, I think, Ramesh Raskar's team in MIT. So maybe if whenever you're going to cover that in depth, maybe a comparison between the two models would be helpful. Yeah.
Thank you so much. You
Yeah.
can email us about your this feedback. I'll convey to a the person who is taking the session on federated learning will definitely try to.
Yeah, because I think that's an important one. The distributed, wherein model to data, there are 2-3 variants are there. So
yes,
thank you.
Yeah, thank you so much. Okay, Prachi, if there are no questions, then probably we can stop here and
there are
on Monday.
Coming in.
Okay.
There are a lot of nice comments coming in saying that it was a great session and we will have more questions once we dive deep into the topics. Yeah, so
sure. Thank you so much. Yeah.
So thank you so much, Dr. Bhushan. It was a very informative and very nice session. And looking forward for many such sessions.
Sure, and I'll be sharing instructions to you, Prachi. I would request you to please share with all the participants. Before the next lectures, we need some installations on your machines. I'll be sharing some Python notebooks so we can do hands-on together.
Yeah. I'll pass it. Okay, thank you, everyone.
Okay, thank you.
Yeah,
I'll stop.